Hello, everybody. Thank you for joining our MIT Inside Track session here at EmTech Digital. I'll say up front, if you have any questions or want clarification, feel free to enter them in the chat window, and we'll be looking for those during the session. My name is Sturtevant. I'm with the Engine. We're a venture capital firm put into business by MIT. We invest into tough tech companies who are working on some of the world's biggest problems. I feel fortunate to have with us today Yibiao Zhao, who's the CEO and co-founder of ISEE AI. So welcome.
Thank you, Reed.
Yeah. So Yibiao, before you started the company, you were working at a lab at MIT. Maybe you can tell us a little bit about your connection to MIT, whose laws, and the questions that you were trying to answer with your research.
Sounds good. Hello everyone. A little bit about myself. I got my PhD from UCLA studying machine learning and computer vision. When I was a PhD student, I was really fascinated by the idea of machine learning. But at the same time, I also realized that most of the work in the area of computer vision, machine learning, focusing on pattern recognition, basically looking for learning a representation from a large data set. But this is a very different, and there's a huge gap to human level understanding that we can, as humans, we can infer the object functions, physics, social behaviors beyond an image. So my PhD work is around area of visual common sense, which is largely influenced by the Professor Josh Tenenbaum at MIT, who is currently the chief scientific advisor at ISEE. So naturally, when I graduate from UCLA, I joined his lab at MIT, working on cognitive and collaborative robots. So we are studying how to build one kind of common sense into the robot theory of mind to help the robot to understand the mental state of others. For humans, actually, we're very good at reading other people's mind. That sounds crazy, but we do. But today's robot are not. So we know that there's a fundamental missing piece in this robot world, and that's why we're focusing on that. So just talk a little bit about today's robot versus the vision. So most of today's robots today are focusing on predefined rules in a constrained environment. However, when we look at the future of the autonomous driving, we are envisioning autonomous vehicles driving in a complex open environment that populated with pedestrians, cyclists, and human drivers. And this is a very different picture compared to the constrained environment that robot can operate today. So that really motivated us to say, okay, the robots in the future have to be aware of the uncertainty in the open environment and react to that safely and properly. And arguably, humans are the most unpredictable part of the environment. So that's why with this vision, we started a company in 2017. We raised the first round led by Engine. We're very thankful to have MIT and Engine support to bring us where we are today.
Thank you. That's very helpful. And when you're operating around, you're trying to come up with a way for robots and software to understand the intentions and be able to on a predictive basis about what people are going to do in a scene. Can you talk a little bit about how you actually construct that model of the possible behaviors, and sort of by observing the scene, how do you infer what the possible behaviors could be? It's sort of a really interesting area that you're working on.
Sure. Yeah, today's AI is mainly based on the predefined rules or a predefined model, feed-forward model that learned from a limited data set. Basically, there's a lack of cognitive capabilities. For example, for driving, today's AV system consider everything as obstacles, and basically we're planning to avoid obstacles. This is precisely why most AV venture fail. Because that's not how humans perceive the world. As humans, we don't just consider the others as obstacles, like the rolling stones on the street, right? We're actually very aware of people behind the wheels. Sometimes when we see someone cutting in front of us, we say, okay, that guy is crazy. How we can know the other people is crazy, right? So, and because we can ask a question of why, and we can also reverse engineer the decision-making process of others, and rationalize their behaviors. And that is a critical piece missing in most of the AV system. And that's what we aim to build in this space. So let me add a little bit. So in a complex situation, it's not just the how we react to others. It's also about how you think others react to you, and how you think others think about you, react to them, so and so on, right? As a result, it's a game theoretical problem under imperfect information. So AlphaGo is an example that solve a game with a fully observable state. However, it's a well-known challenge to solve a complex game with imperfect information. And that's basically what we do here.
That's very cool. So let's bring it. The theme of this EmTech is the age of implementation. So let's maybe we can anchor the audience in what you're actually doing today in the real world with your software. Would this be a good time to show one of your videos?
Yeah, sounds good. Let's do that.
Okay, let's take a look at the first video, please. And you can tell us what we're seeing and what your software is doing as well.
Yes, in the past few years, we're not only building autonomous vehicles, just like we show here, we also successfully deployed our autonomous solution to our customer site. So at ISEE, we don't build vehicles. We're basically building humans, right? So we're building the human capabilities. It is enabling technology to help our customer to operate their yard autonomously, safely, and efficiently.
I remember at one of your early conversations when you were surprised when you did a show and tell in the yard that your driver, your software system, backed up to a loading dock in an unusual way that surprised the regular drivers. Can you talk a little bit about that?
Yeah, so that's very interesting case. So actually, our system, because it has a full visibility of 360 around the vehicles, basically the left side and the right side, there's no difference to our autonomous system, right? But the human drivers, because the tractor trailer backing, there's a huge blind spot on the right side, because people sit on the left side, so they cannot see the right side. They are required to back from the left side. But our vehicle, we can back from left side and right side. When we're backing on the right from the right side in our customer yard, the yard drivers are really surprised. Oh, what's this guy's doing in this blind spot, because it's very kind of very surprised for them. And because of that, it actually improve efficiency, because for the normal drivers, sometimes they have to make a U-turn and then backing from left side. But there's no difference for our autonomous vehicle.
That's a really funny point. Maybe we can take a look at the second vehicle, because there's that game theory, almost like social-like interaction between these robots is fun to see. So let's take a look at the second video.
Sure. Yeah, so for the yard, it's a relatively constrained environment. It's equally complex. However, it is have those very challenging situations, like multiple vehicles stuck at an intersection, and you basically solve the puzzle, right? Solve the game that we mentioned. You have to very quickly make a decision who should yield first. And we program our system to be able to make such a decision. For example, here, right? So two vehicles in an intersection, it will be preferable for one of them to yield. Here's another situation. One vehicle back up, the other vehicle recognize it, so it can yield to the other vehicle. That actually can unblock the yard and make sure that we have an efficient and a seamless workflow in the yard.
That's great to see. It's really fun to watch. It almost looks like they're sentient.
Yeah.
Now, as you were developing the systems, I remember when we first met you, you had hacked your co-founder's hybrid Lexus that had drive-by-wire control controls, and you were performing really fascinating switching. If anybody that knows Boston, Storrow Drive near MGH, where it goes under the Longfellow Bridge, and the lanes are all moving in different speeds, and there's not enough room to change lanes. So you kind of have to. Yeah, I remember you were working on all really interesting social gestures where you try to cut in front of someone, but if they speed up, then you go back behind them and getting other cars to yield to make room for yourself, as well as over the road long haul trucking in some of your early use cases. Why did you settle on the factory yard or that constrained environment? Perhaps talk a little bit about that.
That's a very good question. Actually, warehouse yard or shipping yard is a dark side of the moon. So in the whole supply chain, our customer, they invest a lot of money in the warehouse, inside the warehouse automation. They also invest a lot of money to their over the road fleet. But the yard is actually often overlooked because it's a handover section between over the road and the warehousing dock door. So what it works is it's like a valet service that we provide, where the autonomous, where the human drivers, over the road human drivers, move a trailer into the yard, and then they drop the trailer in the yard and they leave, right? And then when the inside of warehouse need that trailer, our autonomous yard tractor provide a valet service to move that trailer back to the dock door. Same thing like in the other way. And it's a basically under-invest area. However, it's because of this handover, it costs a lot of latency and it costs a lot of unknown. So that's why what I said is a dark side of the moon. It also have a interesting property that it's a very interesting niche. It's a private lot. It's a completely under our customers' control. There's no random people in the environment. All trained workers wear those greenish safety vests. Also, because the private lot, there's no public road regulation. That's potentially another uncertainty of public road AV testings. Yeah.
And I imagine private property, there's one insurance umbrella rather than having to figure out all of the whose fault is it if something happens. And yeah,
exactly.
Yeah, that's great. As you look back at some of the work that you've been doing, are there things that you would tell yourself 4 years ago in terms of the challenges and problems that you've come in terms of making this real? What have you learned?
Yeah, definitely we learned a lot. We learned a lot about this use case. We learned about AV space. So the first thing we learned in this customer use case is it's all about efficiency. Because in the supply chain and the warehousing industry, throughput is the money, right? It is the revenue. And in the very early on, we ran into the challenge that because there are inefficiency. Inefficiency is not caused by our AV system, but instead is caused by lack of transparency in the yard. We don't know what is where, and there's a lot of error in terms of trailer location, area of the trailer state, whether the trailer is loaded or empty. When those error happens, there's a lot of inefficiency that people have to, our autonomous vehicle have to look for the assets, or the human driver have to look for assets. And we realized that, okay, in order to deploy automation, the first step is to digitize, right? To seamless digitization of what is where in the environment. So that's the one area that we learned to improve efficiency. Another part is actually very cool. So when we mentioned that a tractor trailer backing, it is very, very challenging problem. Actually, an interesting example, when we working in the yard, and sometimes there's the OTR driver walking towards us and holding a $20 bill. So, hey man, can you help me to back up my trailer? Because it's very difficult, right? So driving forward and or backing in a very tight space is very hard because basically we're moving a 50-foot trailer is a huge thing into a tight space. Sometimes has less than a foot on either side. So it's very challenging. But our autonomous system, because they have very precise sensors, localization, all that kind of good stuff. It helps the vehicle to be able to very accurately get into very, very tight spot. And sometimes we achieve much better, actually, one-shot backing rate. What that means is human may need to go back and forth a lot of times, and we just one shot.
That's great.
I can save a lot of time too. Yeah.
I have a couple questions coming through. Let's see. Jeff Benanaste has a question. Are your vehicles communicating with each other?
Yes, that's another advantage of the yard, right? So because in the yard is a dedicated environment, private lot, so very easy to set up the infrastructure, and our autonomous vehicle frequently interact with ourselves, unlike the public road. So definitely vehicle-to-vehicle interaction and communication is a core part of this. So with vehicle interaction, you don't only just know where they are, you can also send basically their plan into that other, so make the interaction much easier.
So you can actually optimize the overall plan at a higher global level. Yeah, that's fascinating. Another question from Achilles Prokopakis. Have you thought about using your type of system for autonomous cranes to load containers onto cargo ships with better packing and optimization?
Yeah, actually, that's a great question. Right now, our company is laser focusing on the yard problem, because we think that's a very interesting niche, and that's actually a very good technological sandbox for us to really build the general AI system. However, we do wanted to have the potential to transfer the AI system we built to enable other use cases, like the cases that you mentioned. Yeah.
And in terms of the societal impact, how do you react when people are like, are you removing jobs from the system, and what is the effect that will have as you automate a number of these things that normally employ human drivers rather than software drivers?
Yeah, that's a good question. Actually, when we talk with the customer, surprisingly, they can see a huge potential, even with the system that still have a human behind the wheel, because there's a huge benefit of efficiency improvement, safety improvement, and all the optimization right on top of that. But eventually, we want to build a system that can kind of reduce the effort, reduce the human labor. But those experienced driver can be repositioned to the other skill of a job, like over-the-road driving, right? There's a great shortage of over-the-road drivers, and basically we can help to reduce that problem by automating some part of the supply chain, like the logistic flow.
And then on the other question I might have is how are there any parts of bringing it to the real world that were easier than you expected, or things that you were worried about solving that turned out to be relatively straightforward and tractable?
Yeah, that's a great question. I think in the autonomous driving space, most of the companies entering the space, some of them fail because they are too focusing on solving the unbounded problem first. For example, most of companies were focusing on the robot taxi and also the over the road, like interstate. So basically the problem set is unbounded. You can have anyone, right? You can have anything. It's hard to think about anything that won't appear on the street, right? But the way that we take is we focusing on equally complex problem by itself, but we solve it for a much constrained environment. That's another lesson we learned. We believe it can help us to focusing on the core technology that needed for the complex problem, but limit the space in a way that we can faster to go to the performance and the safety level that needed to deploy it at scale.
And And what's next for the company? How many employees do you have right now? What's your
Sure. So right now we have around 50 people. Still a very lean team, but we're growing very fast because we are in a turning point. Today we have successfully deployed our autonomous system to our customer site, and by deploying, we mean that we actually provide a system that integrated with the customer's existing yard management system. It's just like a Uber app Lyft, Lyft app. So the customer can say, okay, I want to move a trailer from spot A to spot B, right? And when we receive that job, we'll accomplish it. So but at the same time, we have autonomous vehicles on our customer side. There's also human drivers on the customer side. Our customer can send jobs to both autonomous system and also human driving system. So they can get the metrics in terms of what is the service level we can provide, what is the efficiency, how that benchmark with human system to get an understanding of what's the benefit of autonomous system. So by seeing those data, our customer are very excited and really wanted to move to next step to say, okay, what if you can deploy multiple shifts, multiple sites across our network, right? So our existing customer already have thousands of vehicles for us to scale into, and we're very excited about that's the next step challenge, which is how to scale what we have that is working in a customer use case and to a largest space. Yeah.
That's an exciting time for the company. I remember the first time your team came over to show us a demo. You brought over a simulator software and one of those video game steering wheels to show what your automated car would do if other drivers did things near it. And you all certainly have come. To your credit, you've come a long way in your, as we said, in your age of implementation. It's going to be exciting to see where the company goes from here. Thank you for taking the time out of your busy startup day to have this conversation with us.
Yeah, thank you, Reid. We're also very enjoying working with the Engine MIT community. As well as stay in the beautiful engine space. Kind of incubated us from the day one, right, in 2017, and bring us to today. We still have people currently working in the basement of the engine. So appreciate all that support.
No, it's fun. It's great. Well, thank you, Yibiao. Thank you to everybody who joined us for this session. It's always fun. I'll just say personally, always fun for me to see the founders of these companies get out of the lab and into your case, into the yard. So hope everybody enjoys your next session at EmTech Digital. Thank you.
Thank you, everyone.